Thank you for your attention. 1 second, I will find the best position for myself. Okay. So, hello everyone, and name of this presentation was already pronounced, so let's start. Actually, mammalians' humors are under quite the shape of humors are predicted by many variety of the 1 second, sorry, I'm a bit nervous. So, mammalian humors are under strong pressure of the different functions and functional factors and loading by animals and their rate and locomotion on the land. However, whales humors doesn't have this kind of pressure, and probably the variety of the shape of humors have different reasons than other mammalian have. So, as you see, shape of the humors are quite different in the different clade of whales, especially in extinct one. And I think, like our team thinks that it's need have some description, mathematical one, and explanation. And probably phylogenetical signal are also have replaced here. So for testing this hypothesis, we analyzed 3D shape of different species of recent and extant one species of whales. All of them you can see here on the slide. It's around 32 species. And we collected data in many different museums using 3D scanners, and it's allowed us to make this model possible from physical one to 1 second, to the computer one. So to calculate this difference, we use two main approaches to put landmarks on the bone. First was like 499 semi-landmarks that was placed automatically on the bone. And second one, we placed these landmarks on the bone in the most important part of morphological important part of the bone. And there is 34 of these landmarks. Also, we used modern phylogeny of these whales, and most of them was used from Lloyd and Selter publication of 21st year, and 10 species we added by ourselves from different other sources based on different studies. So analyze these using these two approaches for landmarks. We built morphospace to see how this species was placed on this PCA picture, and we can see its first is for first approach, second one for second approach, and we see that actually this method shows that really good group of whales, first like ancient one, Paleocene whales and toothed whales. Yeah, I think it's toothed. No, yeah, it's toothed, and baleen whales here, they are separate even based on morphology of the bone. So what these components mean? First component, we think mean adaptation for water living, and positive plus side, it's animals who is really good adapted for the water, and their bone are quite short, and head of the humerus was a bit rotated comparatively to like less adapted for the water elder ancestor, and minus half of the PCA analyses have any different longer bones, and here you can see medium of this variety and darker pictures for specific species. Second principal component show difference between two clade of tooth and baleen whales, so probably they have some influence of their phylogeny and evolution. And of course, the main difference between them is difference on the proximal part of the bone and shape of these tubercles. So probably here is some influence of modularity and different modularity of the bone. So we compare standard PCA and phylogenetic aligned PCA approach and receive these pictures. So phylogenetic signal is quite significant for this morphology, for their morphology, and so different group probably have different and the most contribution of the part of this graphic is proximal epiphysis that I told already. So probably modularity have really strong influence. What is modularity? It's concentration of integration of some, let's start with integration. Integration, it's ability of the traits evolve together in the one organ, in one part of the animal, and modularity, it's concentration of this integration in one part of the bone, for example. So probably different group have different modularity, and we check this, and we obtain the result that Paleogen whales have more modular bone, which means their bone was mostly evolved by proximal part of their bone. And baleen whales have more integrated evolution, so their bone evolve together in the whole. Also, we make some genetical analysis and receive that we analyzed their homobox gens HOXD10 and HOXD11 and receive that and understand that main trend of evolution of the whales that there is a random walk with relaxed selection, so their evolution of bones doesn't have pressure of selection. So evolution of shape of cetacean humerus is mostly driven by general phylogenetic trends. However, shape in different however, shape of the humerus also evolves towards increasing aquatic adaptation, and different morphological integration of humerus increase during cetacean evolution, and the most integrated situation is in baleen whales, and random walk is main pattern of evolution in gens regulation morphogenesis of humerus of cetacean. Thank you for your attention. Also, big thanks for all collection curators from many different museums, and also special thanks to Mikhail Murlam, who helped to back up data during early 2022. And of course, huge thanks to Ukrainian army who made possible to finish this work and make this presentation here. Thank you for your attention.